Hey, welcome back to another chapter. This is Vedat from Programmership. In this chapter, we are going to talk about concurrency and parallelism in Swift. This topic is very important to make high performance and scalable apps, but it is also dangerous if you don't know what you are doing with concurrency or parallelism. Your code base may contain bugs, so we must be careful. Well, I think it is better to start with explaining the difference between concurrency and parallelism, because in the meaning of both, it may seem they are the same, but actually they are not. Let's understand it with a simple example. Suppose you woke up in the morning in your room and you have got your to-do list for today. Let me write down some tasks for you to do during the day. Let's say the first task is going market for shopping, and the second task is going post office for sending mail, and let's add another one, say calling parents. Yeah, parents are important. So what can you do for these tasks? You can do each task one by one in order, right? First, you can go to market to shop. After that, you can go to post office to send a mail, and then you can call your parents. In this scenario, you did everything in order. You start to do a task and finish it. Then you start for the next one, so on and so forth. Well, this is how serial processing works in software development. Say serial processing. When your program starts a task and waits until it is finished and then starts for the next one, this is serial processing for the tasks. We can also call tasks as a thread in software development. Here, let me write down task is actually thread. I know I haven't explained concurrency and parallelism yet, just bear with me. Let's get back to our example. Suppose you are on the way to market and it takes about half an hour to get to market, and suddenly you decided to use this half an hour wisely. You called your parents and had a talk with them when you were on the way. Then you arrived at the market and hang up the phone. So what happened here? You just finished a task which is calling your parents while you were on another task. Right? You used available time of going to market as doing another task. After you get back from shopping, you will have finished two tasks already, right? So this is how concurrency works in software development. When you have multiple tasks or threads that must be done as soon as possible, concurrency is a good option, because when a certain task has available time, we can use that time for doing another task. What about parallelism? Let's get back to our example again. Suppose you have no time to go shopping or post office, but you have some good friends that can do these tasks for you. Let's call your two friends Adam and David. You get Adam to go shopping and David to go to post office. There is only one task left, which is calling your parents, and you call them. So what happened here? You just finished each of your tasks simultaneously. It is alright if your friends helped you. At the end of the day, all of your tasks were finished, right? So this is how parallelism works. If your device processor has multiple cores, which is more than one, then each core can handle one different tasks or thread. In this case, those tasks were handled simultaneously. You can use parallelism if your device processor has multiple cores, and each core can also use concurrency within itself. This is the difference between parallelism and concurrency. I hope it was clear enough. So in software development, working with threads needs a little more knowledge, because managing all threads concurrently and parallel is not an easy job. But don't worry, there are technologies out there that can help developers to manage those threads. In Swift, I want to talk about two of these technologies. These are GCD and operation queues. Let me write down GCD and operation queues. Let's start with GCD. GCD stands for Grand Central Dispatch. Let's write it as well. GCD is Grand Central Dispatch. It is also known as dispatch queue. Let's say it is equal to dispatch queue. Dispatch queues provide three different kinds of queues. So these are serial queues, the other one is concurrent queues, and the last one is main dispatch queue. So let's start with the serial queues. Serial queue provides you to execute multiple tasks synchronously. That means the second task will not work until the first task is finished, or the third task will not be executed until second task is finished, so on and so forth. Remember our to-do list example. If we start a task and process it until it is finished, then do the next tasks, it is serial processing. Serial queue allows you to do that. For example, if you need a certain task that must be finished before executing the next task, it is pretty useful to use serial queue. Suppose you have a login page in your application and you want your user to log in before displaying the next screen. You may want to get user info from the server and display it. So in this case, we have to make sure user login request is completed. Otherwise, we cannot execute tasks for getting users info from the server and display it. We can use the serial queue for that. Our first task will be a login request and the second task will be displaying user info. Let's create a basic structure and see how it works. Let's say struct, and I'm gonna call it as user operation. Inside struct, let's create our login function. So in the login, we must have two parameters, which is username and the password. Let's type also string. So I want to create a simple logic that will represent the passing time while making network requests. Let me create a private constant which will be a value for iteration in login request. Let's say login iteration is, I can say 100,000, and create another constant for the display info request. Let's say private let display info iteration, and I want to set it as 10,000. All right, also let me create a boolean property for getting the information about user, whether he is logged in or not. Let's say private, that will be variable, and let's say was logged in. First we can say it is false, and inside the login function in the first line, let me print login request started, and in the next line I can create a basic for in loop and do some calculation inside for representing the passing time while making a network request. Let's say for blah blah in 0, it will start from 0 until the self.login iteration. And inside the for in loop, I can just say, for example, let number 1 is 50, and also let's create another one. Number 2 is equal to number 1 times number 1, and also we can say something like that just for making basic calculation. So I just created these lines for nothing, just for making some calculation. Here at the outside of for in loop, I can say if username parameter is equal to password, then we can say self.was logged in is true. Otherwise, we can say it is false. Just like that. And at the end of the login function, we can print and say login request ended. We can also find out how much time it takes for this for in loop operation. There's a function called cf absolute time get current, which returns the absolute system time. Let's use it. So after the first print, I can say let started time is equal to our cf absolute time get current, and also just before the last print I can say let finished time is equal to again cf absolute time get current, and inside the last print we can say time is finished time minus started time, just like that. So it seems we have an error. I think we need to make our function mutating just because of structure. Let's say mutating. All right, let's also add another function for displaying the user info. Let's say func display info. We don't need any parameter, and I think it will be better just say mutating for this function as well. So it is all right, just copy all of the body of login function and paste it here. Let's make some edits. We can say display info request started, and for this we can say the display info iteration. And also instead of this, we must control if the was logged in is true, then we can say print login succeeded. Otherwise, we can just say the login failed. Here in the last print statement, let's say display info request ended, just like that. It seems we are ready to execute these two tasks in serial queue. To do that, we will create an instance of the dispatch queue class. Here at the outside of structure, let's create an instance of dispatch queue. Let's say my serial queue is equal to dispatch queue. Dispatch queue accepts two parameters which are label and attribute. In default, the attribute is defined as serial. If we don't specify any attribute, it will be serial. Otherwise, if we want to make it a concurrent queue, then we need to specify it. For the label, let's say serial queue test, and for the attributes, if I say concurrent, then it will be a concurrent queue. Just because we are testing the serial queue, so I don't need the attributes parameter at all. Let's delete this. All right. Also, I will create an instance of user operation structure. Let's say var my user is equal to user operation. Let's use my serial queue. There's a function called async which accepts a closure as a parameter. Don't forget, this async function will run the closure that you pass as a parameter immediately. Let's use it. Let's say my serial queue dot async, and inside the code block of this closure, I want to call login function. Let's say my user dot login. For username, I can say Vedat, and for the password, again, let's say Vedat. I'm gonna add another queue for calling the display info. Let's say my serial queue dot async again, and inside my user dot display info, just like that. Here we just defined two different tasks and put them in the serial queue. Let's hit run and see what happens. Let's say run. It takes a few seconds to finish the operation. As we can see, at first, login operation started and finished, then the display info operation executed. Even though display info operation takes less time than login, it won't be executed until the login operation is finished because we put them in serial queue. I think you got the idea. Let's talk about concurrent queues. We already learned what concurrency is in the to-do list example. Concurrent queues provides to run multiple tasks asynchronously. Now I will create another instance of dispatch queue class for concurrent queue. So here let's say let my concurrent queue, that will be an instance of dispatch queue. The label will be concurrent tests, and remember the attributes parameter, that will be concurrent, just like that. And instead of my serial queue.async, we can just copy the my concurrent queue instance and paste it here. Let's hit run and see what happens. Hit run. As we can see, when it runs concurrently, the task which needs a shorter time will be finished earlier. Here, the display info operation was finished just before the login request because it needs shorter time than the login. And just because login request didn't finish yet, here the if statement will not work. It says login failed. What happens if our login request would need shorter time than display info operation? Let's make the login iteration property shorter. Here, let's say 1000, and let's hit run again. And this time we can see the login operation was finished before the display info, and it says login succeeded. It works. Well, we can see how dangerous it could be using a concurrent queue if we don't know what we are doing. Again, be careful. Let's talk about main dispatch queue. In applications, there is a main thread which is used for user interface operations. If we don't use any different threads for our tasks, those tasks will be executed in the main thread. This is not good for performance because main thread must be used only for user interface face operations. Otherwise, our application screen may freeze because of main thread extra tasks. Only if we need to do something with UI components, then we must use main thread. Suppose you are in another thread which is created by dispatch queue. You did some task on a concurrent queue and you want to update UI components in your concurrent queue. For that, we must access the application main thread. To do that, we can use main dispatch queue. With main dispatch queue, we can run a task in the main thread even we are on another thread. Let me show you how to add code in the main thread when we are in the first concurrent queue, which is login operation. Here in the next line, just say dispatch queue dot main dot async, and inside we can put our codes that will be executed in main thread. Let's just say print, and inside this is main thread. We can deal with UI components here. It is pretty useful to use main dispatch queue. Think about a task which takes amount of time to finish. You can run this task on a concurrent queue and display a progress screen to your user until time-consuming task completed. When it is completed, you can close progress screen within the main dispatch queue. It makes sense, right? Well, remember, async function that we used in dispatch queue run tasks immediately as it is added into queue. There is another function called asyncAfter, which allows you to execute tasks after an amount of time that you specify. Let's run the display info concurrent queue after 2 seconds. For that, we can just say asyncAfter, and here I can just say the deadline will be now +2. Here we just said run this code after 2 seconds from now. This is how asyncAfter is used. Alright, finally, let's talk about operation queues. Operation queues is an alternative to GCD, which is dispatch queue. We can use operation queues to run multiple tasks concurrently as well. In operation queues, each task that we want to execute known as operation. So we can pass multiple operations into operation queue to run them concurrently. There is also a class called operation, which provides to create our own custom operation subclass. We are gonna talk about it later. Remember, in GCD, async function run the tasks when we add it into queue. Somehow, you may want to add all the tasks into queue first, then run them concurrently after all the tasks were added. It is possible to do that in operation queues. There is a class called operation block, which is subclass of the operation class. First, we add all the tasks into operation block instance and then pass this operation block into operation queue. In this way, we can add all the tasks first and then run them. Let me show you how to use block operation queue to call login and display info functions. And let's delete these lines. And also we can increase the login iteration value. Let's say 100,000. Here I will just create an instance of user operation structure, and then I will create another instance of block operation. Let's say block operation is equal to block operation. And for the initializer, we can just add a task. Let's say for the first task, I can say my user.login. And for the username and password, let's give the same value. In the next line, I can just say block operation dot add execution block, and inside let's call the display info, and at the end we need to pass this block operation instance to operation queue. Through that, let's create instance of operation queue. I can say my operation queue is equal to operation queue, and I can just say my operation queue dot add operation, inside just say block operation, just like that. Here, first we added our tasks into block operation and then passed the block operation into operation queue to execute. Let's hit run. It works. Because of login operation needs more time than display info operation, it says login failed. Let's change the login iteration parameter and make it smaller than display info operation. Let's make it 1000 again. And here, let's hit run. And this time the login operation has less time than the display info operation. In the display info it says login succeeded. Well, if you want to run the tasks immediately as it is added into operation queue, we don't have to use block operation. We can just pass these tasks into operation queue instance just we did in GCD. Let me show you. So we can delete this block operation, and here let me create the instance of operation queue again. Let's say operation queue, and instead of this I can just say my operation queue dot add operation. Here just add code inside the add operation block. I can say my user dot login and give same value, and in the next line I can say my operation queue dot add operation. Just execute the second operation, which is display info. So sorry, my typo, it must be display info. Let me correct this. All right, and let's hit run. It still works and says login succeeded. Finally, let's talk about custom operation subclass. When we create a class and drive it from operation class, we need to override a method called main. When we pass our custom class into operation queue, this main method will be called by operation queue automatically. So we must design our class on that purpose. Let me delete all of this and create a class called vehicle. Let's say class vehicle, and this class will be the subclass of operation class. Remember, if we use operation class as parent, we need to override the main method because it will be called by operation queue. Let's say override main method. So I want to add two parameters and a method called move. Then I will create a simple logic. Here, let's say var vehicle name for the first parameter, and also let's say var distance, that will be integer, and let me create a basic initializer for our parameters. Instead of override, I can just say vehicle name is string for the first parameter and the distance is also string. Inside the initializer, I can say self.vehicle name is equal to my parameter and self.distance is equal to second parameter, which is distance. Sorry, it must be integer type, and I want to create a function called move, and inside the move function, let's start with parents. We can say the vehicle name started, and in the next line I also want to print how much time this operation takes. So let's say let's started time again, that will be cf absolute time get current, and in the next line let me create again a basic for in loop. Let's say blah blah, and it will start from 0 until the distance value, and inside the for in loop create some simple calculation for consuming time. So var num2 is equal to num1 time num1 again, and in the next line let's say number1 plus number2. So here instead of blah blah I can just put an underscore because I don't want to use a value from this range. So at the outside of for in loop, let's get the finished time. That will be again cf absolute time get current, and in the last line I can say print the vehicle name arrived, and the time is finished time minus started time, just like that. As I said, this main method will be executed by operation queue, so let's call the move method within the main function. Now let's create an instance of the operation queue and pass some vehicle class instance as operations. Let's say var my operation is equal to operation queue, and in the next line let's say my operation dot add operation. Here I will just create a basic instance of vehicle class. Let's say first car for the first tasks, and distance I can say 10,000, and let me copy this line, paste it a few times. For the second task I can say second car, and for that let's say third car. The second car value can be 5,000 and the third car distance value can also be 1,000. So let me hit run. we can see all the 3 cars started. The 3rd car arrived first because it has the shortest distance value, and then the 2nd car arrived. Finally, the 1st car arrived, which has the longest distance. If you want to run the tasks which you put inside operation queue serially instead of concurrently, there is a property called max concurrent operation count that provides how many tasks should work concurrently. If we set its value 1, then our operation queue will run 1 task at a time. It will be serial. Let's see that. Here, after creating the instance, I can say my operation dot max concurrent operation count is equal to 1. And let me hit run again. As we can see, all the tasks was executed one after another in serial. Alright, that's it for this chapter. I hope you have enjoyed the chapter and learned something about concurrency and parallelism. See you in the next one. Goodbye.